Hello everyone, in this video we are going to talk about data preparation by One Hot Encoding. So we will see some of the very important submodules which will be required for data preparation and cleaning purpose. So let us just start. So by the end of this video you will be able to replace all the null values in a dataset by simple imputer, understand label encoding along with proper code and output, understand one hot code encoding with code and output, split our dataset into training and testing. So this is the reference dataset which we are going to use. Ethnicity and height weight will survive till 70s. So I have the same dataset was there in my previous video. Only the first two rows were there. So here I have made quite a few number of rows. So you can see some of the null values are there. So what we are going to do is that we can replace these null values by the average of these values or by the median of these values, right? Because we cannot compute with the null values, we cannot go ahead. And also I told you that we need to replace this by some encoder, white, African, because computer needs digits, right? So we will do that first. Using simple imputer, it is used to replace null values with some generalized value like mean or median. First we divide our data into x and y using ilog. Suppose this is all the rows, this is signifying all the rows, and from the starting till the end except the last one is our x, and only the last one is our y. So now we do from sklearn.impute import sample imputer, simple imputer. So now we assign an object missing equals to simple imputer missing values equals to np.nan and strategy equals to mean. Strategy means what is the thing by which it will get replaced. What will get replaced is the missing values, and the argument of strategy means by what it will get replaced. By what? By the mean of the column, by the median, or maybe I have used here mean. So what we do here, first we do fit transform of this data. So we can also do it step by step, like missing equal to missing import, first fit and then transform, or we can just do direct fit underscore transform. The result will be all the same. So now we do the label encoding. So it is used to assign numerical values to the categorical data from sklearn.preprocessing import label encoder. So these are all simple coding. You need to know this, and I will show you in the code demo of my next video that without memory based stuff also how you can easily, without memorizing this code, basically how you can easily do this coding. As of now you know this, that first we assign an object x underscore label encoder equals to this. As we know, Python is an object oriented programming language. So we assign an object and then we change the first, what is this, all the rows and the first column, right? Then we change the first column with fit transform. Now what you see, this is the output. White is replaced by 2, and African is replaced by 0, and Asian is 1. This is the encoding which occurs to the first column. Now let us see this one hot vectorization. So first you need to know, if you search about this in the internet, you will find this code, this piece of code in many places you will find. But this is outdated and it is now updated. If you use this, it is no more valid. So this is the new one. From sklearn.preprocessing import one hot encoder. From sklearn.compose import column transformer. Column transformer equals to this is an object, column transformer equals to the main function. First I give encoder, then one hot encoding, comma 0 means which column I am gonna encode, and the remainder equals to pass through. Now this needs some explanation, so just wait. X equals to np.array column transformer fit underscore transform d type string. So you see here carefully. First we import preprocessing as one hot encoder and compose at column transformer. What is this column transformer and why do we exactly need it? So actually what used to happen earlier, what is this code and why is it wrong right now? what used to happen earlier is that people used to do level encoding and one hot encoding as in different ways, like I showed. So that time one hot encoding was used like this, but it is seen that data scientists use one hot encoding and level encoding almost together, always almost together. So what we do, we have now and we have now got our things more simpler. We have another column transformer. This is a new module added to Python, very latest. This, what it does, it can do one hot encoding functions without even doing level encoder. Note that to make you understand level encoder, I first taught you what is level encoding, but it is not necessary to first do level encoding and then do one hot encoding. You can directly do with one hot encoding also using this column transformer. So the first requires a name. It can be anything. I have given encoder. One hot encoder, the function which you are going to perform, on what you want to perform the function, that is this, and then the remainder equals to pass through. You can give remainder equals to drop also. What remainder means, the remaining columns. This column you are transforming, what you want to do with the remaining columns? You can drop the remaining columns. No, I don't want to drop. I want to just pass through. So I just placed here remainder equals to pass through. Things will be more clear with more code demonstration on the next video. So you can see the output. See, the first one was 0, 1, 2. So it's now 0, 1, 2. You see, first column was first row was 2. So there is 1 in the 2. So this is the encoding to the in binary form. It is there, right? And if we do normalization of this data, the entire data will fall under 0 and 1. So it is quite helpful, and you can see we can do now reduction of dimensional. Why? Because you can see at a time, out of in the 3 columns, at a time only one is 1, the remaining are 0s. So suppose if I drop this row, this column, will I lose any data actually? No, I'm not going to lose any data, because I know that one out of 1 and 2 column, this is 0 and this is 1, so other has to be 0. If I know that these two are 0, the other has to be 1. If any one is 1, the other has to be 0. If both are 0, the other has to be 1. I know it, so I can literally drop this row while doing our algorithm. We will see that when we do more advanced stuffs like Titanic datasets. So this is the way how you can train, test, split. It is used to split our data into training and testing. So it is quite simple. From sklearn.model selection, import train, test, split, xtrain, xtest, ytrain, ytest. These are the 4 matrices which are going to take the values test, train, split from x and y, from our assignment of x and y. The test side will be 33%. Random state equal to 0. If we don't assign the test side, its default value is 25%. Random state equal to 0 means it will be in an ordered fashion. It won't be in the random. The way it is there, it will be output will also be there in stored in the training and testing data. So suppose I have 100 rows. What will how much will our training, this x train consist of? Can you tell? It will be 66, right? 67. You can say 67%, and x test will be of 33%. So similarly for ytrain and ytest also. Now we can do feature scaling like the standardization and normalization, as I told you in my next video. So now our next video will be on the entire code demonstration of our previous 2 videos. So thanks a lot. Meet you in the next video.